Okay, welcome to this next video. In this one, we're going to explain how to install and use the software development kit from Fujitsu. So you will be able to download these files from Moodle. The first one is going to be the requirements file, in which we will explain which libraries are needed. In this case, it's going to be Jupyter, basically, and then the digital annealer development kit from Fujitsu, which is here. This has been provided by Fujitsu. You can download it offline. So in this case, instead of installing it from pip, downloading it with the pip command, in this case it will be installed from a local library. So in order to start, let's open a terminal. You do Python m notebook. This will open the web browser, and in there we will be able to review both the requirements file that we discussed, Jupyter, as you can see, and then the Digital Annealer development kit, which in this case you can see that it's being obtained from this same repository. The dot indicates, folder. The dot indicates the current folder, and within the current folder, the ADK lite.tar.bz, bz2, which is here. It's a compressed file. If you were to open this, you will be able to see the contents of the library. You can decompress it and so on, but in this case, it's not going to be needed. So in order to test this, we are going to create a Jupyter notebook. First, use a terminal, and you are going to do pip install r requirements.txt, which is going to go through that list and it's going to make sure that everything is installed. In my case, everything should be already there, because I tested this a few moments ago. In your case, if you find any issue, whatever, reach out and we will try to solve it. It's taking some time because it has to build the library. In my case, you can see that everything is already installed, requirements satisfied, so it's not going to really make much of a difference. But if everything looks good, you will be able to obtain a successful message, and with that you will be able to use the library. In my case, it uninstalled. Well, everything seems successful, so okay, let's go. In this case, we're going to use from the adk.beanpol binary polynomial import bit array shape bar shape set and beanpol. We will be discussing this in a moment, but the idea is that these are the classes that are going to help you define a problem, which we just started the subject, so we are not going to go through that, but we will need a small problem that we will implement in just a moment in order to test that everything is working. Don't worry, we will have a lot of additional contents in order to how to model problems. For now, we will just give you one, we will test it, and that's it. You will also need the simulator, which is from the adk.cubo solver cpu import cubo solver cpu. If everything works properly, you should be able to execute this if you have installed your libraries correctly. As you can see, it has been executed. This means that it was correctly imported. If you got here, most likely everything was correctly installed, but we will go ahead and we will execute one example. So we'll start by preparing the sampler, Cubo Solver CPU. This will need a few parameters. You have multiple options. We will discuss them throughout the subject, but for now we're going to only cover two: number of executions, independent executions of this problem, and for each one of those executions, how much iterations we want to execute it for. You can call this sampler, solver, whatever you want. Then we have to define the problem itself, depending on the specific problem, model, constraints, use case. This is going to change, but for now we are going to prepare one that is as simple as possible. Don't worry about this part. We are going to define a set of binary variables for a problem, bit array shape. So this is going to be an array of binary variables. In this case, I'm going to define this array as x, so that means that all the binary variables in this array are going to be called x0, x1, x2, whatever. It can have multiple dimensions like x00, x01. In this case, I'm going to go with a single dimension with a single variable, as you can see here. So I'm only going to have one bit, basically. And just for reference, the name of the axis, binary. This is not relevant again for this, but for example, if you have a problem with multiple axes, you can say like time and location and or asset, whatever you are playing with. In our case, it's irrelevant at this point. We only want to execute something. Var shape set is going to be var shape set binary variables. The idea is that we are going to combine the different variables into a set that will be provided to the to the model. The Kubo model is going to be being poll created with that var shape set, and this is going to be the Kubo model. Now we can start to implement coefficients and constraints. We will go through this in the subject. Q add term. I'm going to add a single term with a coefficient of 1 to the variable x0. So x0. That's a model as simple as it can be. And then we are going to look for the global minimum in that model, which is the purpose of the digital annealer development kit. So sampler dot minimize the model Q, and we are going to, you can see that in this case the model Q is just x0 multiplied by 1. That's it. Not a lot of information. Print response. Okay, let's go through this. We will be discussing this in detail throughout the subject, but in this case, it found that in order to minimize this, it needs to assign a coefficient of 0 to this variable, and that obtained an energy, the frequency of the number of runs in which this solution was found. And you can see a lot of information that we will discuss, like the elapsed time, the details about how it was solved, and so on and so forth. But if you obtain first a successful import here, and then a response that looks like this once you execute something, this means that the library is correctly installed and you can go ahead with the rest of the subject. That will be all for now. Thank you so much.